Okay, this question is about the transition metals, everyone's favourite, and it starts off with a really weird way of writing something down. So when I looked at this as an exam paper, I had to look at this statement a couple of times before I understood what was going on. So I've got my copper hexa-aqua ion, and then I've got two Cl2. So it looks like like a chlorine molecule. It's not. What it really is another way of writing copper chloride as a solid, or copper chlorides as in I'd have copper 2 plus and I'd have chloride 1 minus. So I'd have that ionic bond really. So moving on, state the type of bonding between the oxygen and hydrogen in this compound. So it started off by writing this out in a really funny way, but then it's saying actually I've got oxygen and hydrogen in this compound in the form of H2O. State the type of bonding between oxygen and hydrogen in that compound. So it's asking what is that type of bond, and that bond is a covalent bond. So it's a bit of a strange start to a transition metals question, but just stick with it and just put what you know, okay, because you all know how to do that. State why the chloride ions in this compound are not considered to be ligands. So the chloride ions in this compound aren't ligands because they're not providing electrons to form a covalent bond. So I'm going to say that in some language that the Merck scheme is going to like. So chloride is not donating a lone pair of electrons to copper 2 plus, or I could say chloride is not forming a coordinate bond. Okay, next question. An excess of ammonia was added to sample of solution A to form solution B. Write an ionic equation for the reaction that occurs when solution A is converted into solution B and state the colour of solution B. So this is asking us really for a ligand exchange reaction. So my ionic equation is going to be the metal ion complex ion. So I've got 6 waters around my copper 2 plus, and I'm going to react it with an excess of ammonia. So if I've done my transition metals revision, I will know that in excess of ammonia with copper, only 4 of the waters are replaced. So I get copper. I've still got 2 H2Os left, and I've got 4 ammonias. I've still got a 2 plus ion, and I would need to have kicked out 4 waters, 4 H2Os, and the colour of that solution is deep blue. So, oops, I would get 1 mark for the equation and 1 mark for the colour, so that's 2 marks. The next question says, aqueous sodium carbonate was added to another sample of solution A to form a blue-green solid C. Identify the blue-green solid C. So we've got a carbonate and copper. Again, if I've done my revision for this, this is easy, this is straightforward. So this is copper carbonate, and that is my blue-green solid, my blue-green precipitate of copper carbonate. Okay. Reagent D was added to another sample of solution A to form a yellow-green solution. Identify reagent D, write an ionic equation for the reaction occurs when the yellow-green solution is formed from solution A. So the only yellow-green solution that I can make with copper is when I add concentrated hydrochloric acid. And my equation, I need my copper, so I need solution A again. So I've got 6 waters surrounding my central copper 2 plus ion, and I need 4 chlorides because only 4 chlorides can fit around. And each have got a negative charge, so it takes my total charge down to 2 minus, and then my 6 waters have been kicked out. So I'll get 1 mark for my reagent and 1 mark for my correct equation. Last question on this, explain why colorimetry cannot be used to determine the concentration of solutions containing copper Cl2 minus. So copper, a different form of copper chloride. In your answer, refer to the electron configuration of the metal ion. So there's a massive clue in that last statement. So if I just look at this thing here that I've got, it's got an overall charge of minus. Chlorine must be -1, giving me a total of -2 from the chlorines because I've got 2 of them. That must mean that the copper is in its +1 oxidation state. Now when copper is in its +1 oxidation state, it has lost its 4s1 electron, and that means its 3D subshell has got 10 electrons in it. So it loses that electron and it would form a +1 ion, but it doesn't have an incomplete D subshell. Okay, so it can't form a colour compound because the electrons can't move between the D subshells. Okay, so colorimetry is going to be useless because this copper form of copper chloride isn't going to be a coloured solution. So I'm going to say that. I'm going to say that copper chloride, this copper chloride is colourless because it contains a copper 1+ ion that has a full 3D subshell. And I'd essentially need both of those statements or words to that effect to get those 2 marks.